The dramatic growth in the textile industry might have been cut short if waters from rivers and streams had remained the only source of power for factories. However, this was not the case, and a solution was found to the reoccurring and age-old problem of energy and power. We cut now to our live reporters who are pondering the problem of energy here in Britain.
I'm Cordelia Crawley.
And I'm Poppy Gibson. Our top story this morning regards the shortage of energy that has become particularly severe here in Britain.
All human beings require quite a bit of energy just to function, and we have relied for years upon plants and animals for our sources of energy. Almost all energy comes directly from the land: grain for people, hay for animals, and wood for heat and power.
When agriculture was first developed, people were able to increase the number of plants available, therefore increasing the supply of energy. Some of those plants could be fed to domesticated animals stronger than humans, like horses, who could convert those plants into work.
Humans have also used their knowledge and craftsmanship to convert energy from one form to another. During medieval times, people developed water mills to grind their grain and windmills to pump their water. Most recently, effective use of water and wind have let us accomplish more, including intercontinental transit.
Nevertheless, our society continues to rely on plants for energy even now, and human beings continue to do most of the work.
Here in Britain, men who plough and women who weave are only able to exert a certain amount of power. Human muscle and horsepower can only take us so far, and can only produce so much.
As Cordelia mentioned earlier, all of our energy currently comes from the land, which is also the principal source of raw materials necessary for industrial production. Wood and flax for clothing, leather for shoes, wood for housing, tools, and iron making. Regrettably, it's difficult to expand the amount of available land, and therefore there are limits to improvements.
Moreover, recent population growth has left us with fewer forests and more grain and hay, and wood, which is remarkably important for industry, is in ever shorter supply. Our previously prosperous iron industry here in Britain began to decline in 1740 due to a lack of charcoal or processed wood.
Our energy failures in Britain allowed Russia to temporarily become the world's leading iron exporter. However, they too reached the same barrier of inadequate energy as us.
This lack of power and resources leads us to ponder the question, where in our small country is more energy to be found?
Here with us this morning from Glasgow, two of the members responsible for overcoming energy disadvantages in the mining industry, Thomas Savory and Thomas Newcomen. Good morning, gentlemen.
Good morning, Poppy, Cordelia. It's lovely to be here.
It's a pleasure as well.
Now, Mr. Savory, what events and reasons prompted you to create the first steam engine in 1698?
Well, I'd seen the way that coal was used in Britain as a source of both heat in common homes and small shops. However, I noticed that coal was not used in power machinery, and saw the massive potential coal had to solve our energy crisis.
If you don't mind me interrupting, Thomas.
Oh, nonsense. Not at all, Thomas.
Yes, well, 1 pound of coal contains more or less 3,500 calories of heat energy, and a determined miner can unearth about 500 pounds of coal every day by hand. That same miner can produce about 1 horsepower per hour. In contrast, even a primitive and inefficient converter that, say, transforms only 1% of the heat energy into coal in mechanical energy can already produce 27 horsepower per hour.
And those inefficient converters that Thomas mentioned are exactly what our steam engines were.
See, another reason why Thomas and I here created steam engines is because as more coal was produced, mines had to be dug deeper and deeper and began to fill with water. Mechanical pumps requiring about 500 horses for power had to be installed, and that type of power was incredibly expensive and inconvenient.
Our steam engines were a shot to conquer those disadvantages.
So how exactly do your engines work?
Well, both of our engines burn coal to produce steam, hence the name steam engine. That steam is then infused into a cylinder or reservoir. In my engine, the steam is cooled, which creates a vacuum that allows already existing pressure in the Earth's atmosphere to push the piston and operate a pump.
As of now, our engines are operating mostly in English and occasionally Scottish mines, pumping water from coal mines.
All of us here at Channel 2 News look forward to hearing from you both in the future.
Thank you so much for your time, gentlemen. Back to you, Pippa.
Thanks, Poppy. And other exciting news here at Channel 2, we have James Watt, the Scot responsible for improving the steam engine.
Welcome, Mr. Watt. We're so happy you could make it this morning.
When did you first become interested in begin critically studying the steam engine?
I was a craftsman who made scientific instruments under the employment of the University of Glasgow at the time, actually.
Scottish universities are known to pioneer practical technical education, correct?
Yes, they are. A few years after my employment, the university asked me to repair a Newcomen engine that was being used in a physics class. While I was repairing it, I noticed why the Newcomen engines were so inefficient. For every stroke of the piston, the cylinder was being heated and cooled. During my free time, I began working to fix this problem. After a series of mishaps, I added a separate condenser for the steam so that the cylinder wouldn't cool when the steam was condensed, increasing steam engine efficiency.
Mr. Watt, how did your idea become a reality here in Europe?
I suppose I have the advanced British economy to thank for that. I need skilled workers, money, and engine parts to make my invention practically applicable. A partnership with a toy company here in England provided me with money, and I found skilled mechanics to work with the engines. I was gradually able to buy large amounts of precision parts.
You should be proud. These days, your steam engine is a practical and commercial success here in Britain and is also considered to be the most fundamental and important industrial advancement.
Yes, socially it has given humanity unlimited power at their disposal because engineers can invent equipment and common people can prosper. Additionally, economically, it's become vital to several key British industries including the mining industry, the cotton industry, the flour industry, the malt industry, the flint industry, the sugar industry, and the iron industry.
In the mining industry, steam engines drain mines, making coal production more efficient.
In the cotton, flour, malt, flint, and sugar industries, steam power has replaced water power, and the steam power plant is widely regarded as the source of these industrial successes.
Steam power perhaps impacted the iron industry most profoundly, however. Correct me if I'm wrong, but powerful steam-driven bellows and furnaces helped iron makers switch from limited charcoal to unlimited coke, which is made from coal when producing iron.
Indeed, Henry Quart's puddling furnace developed in the 1780s also positively impacted the iron industry. It allowed pig iron to be refined. Strong iron workers called puddlers cooked molten pig iron in a vat and raked off globs of refined iron for further processing. He also created steam-powered rolling mills which were able to finish all forms of iron.
Since then, iron has evolved from an expensive and rare material to one central to the economy.
Thank you so much for your time this morning, Mr. Watt.
Oh, it was my pleasure.
Steam power has recently been used to power new inventions.
Although the second half of the 18th century has seen a lot of construction of smooth roads, only passenger traffic benefited from them. Shipment of freight over land still relied only on horsepower and was limited and quite expensive since shippers had to use rivers and canals to ship heavy freight.
In 1800, an American ran a steamer on wheels through city streets. In 1820, engineers here in England created steam cars that could carry 14 passengers at 10 miles per hour. However, they were loud and scared horses in addition to damaging the new roads themselves.
Since the coal industry had long been using rails to move coal wagons, when a rail capable of holding heavy weight was created in 1816, revolutionary experiments involving steam engines on rails began.
George Stephenson was the first man to build a successful locomotive, and his rocket sped down the Liverpool and Manchester Railway, the world's first most important railroad, at 16 miles per hour in 1830.
Liverpool to Manchester line was a financial and technical success. So many private companies hurried to build more rail lines, and many countries tried to imitate our success here in Britain.
You may be asking why the significance of the railroad was so great. We cut now to our live reporters on the Liverpool to Manchester line to answer your question.
Thank you, Pippa. Firstly, railroads reduced the cost of shipping freight dramatically, and advanced had many economic consequences.
Previously, markets have been small and local, but after the railroad lowered transportation costs, markets became nationwide.
Large markets encouraged the growth of larger factories with more progressive technology. Those factories could make goods more cheaply.
In all countries, railroads resulted in a demand for unskilled labor and have succeeded in creating a class of urban workers. Landless farm laborers and poor peasants began leaving their villages to build railroads.
Many have called the railroad the last and culminating invention of the Industrial Revolution.
Justly so. The railroad dramatically changed the ideas and viewpoints of our entire society.
Zooming down the rails at speeds up to 50 miles per hour, the railroads, especially the Liverpool to Manchester line, revealed the power and increased the speed of our new industrial age here in Europe.
In addition, they dramatically changed the lives of common people.
Just several years ago, in 1851, London was the site of a world-famous industrial fair called the Great Exhibition. Held in the newly built Crystal Palace, it is an English masterpiece made entirely of glass and iron. The palace was and continues to be an exhibition of the great wealth we possess here in Britain. The Great Exhibition attracted over 6 million visitors, many of whom journeyed to London on the new railroads, and all of whom were awed by Britain's bragging rights, otherwise known as the Crystal Palace.
There are so many companies displaying their products here and from so many different countries.
Britain, small as it may be, is obviously the workshop of the world, as evident from the magnificent Crystal Palace and the huge fair held there.
The Crystal Palace is strikingly modern. They got nothing like it where I'm from.
I came here on the railroads. They're spectacular! Thank you so much for joining us here at Channel 2 News. I'm Pippa Nightingale.
And I'm Ron Burgundy.
Be sure to join us back here tomorrow for more of the top news at the bottom of the hour.
Burgundy out.